Hi, this is a supplementary math lesson covering lesson 72A in your textbooks, and I'll be working off of the problem, example problem 72.1 on page 290 in your textbooks. If you want to go ahead and take a pause on this video and turn to that page 290. Okay, so what we are doing, we are just simply determining the equation of a line from experimental data. Now, in our previous problems, they've given you plots of data represented by the points on the graph here, and they have the line drawn in. Now, as you see in this, from here on out, they're just going to give you the points, okay? So you have to determine the equation of that line on the graph, okay, with just the points. So the trick is drawing in a line to fit those points, okay? Now, the book says it's not an exact science here, okay? It's kind of an art form as well as a mathematical tool to do that. They give an example. There's a line to the left that they could have drawn that would go up this way, connecting the points on the left. There's a line here that would connect most of the points on the right. Okay, our line should be somewhere in the middle of those. So when I draw a line, you know, your first goal is to have the line go through all or as most of the data points as you can. Now, when your points get scattered like this, that's an impossibility. Okay, so the second rule of thumb then is you want an equal number of points on either side of your line. So the first rule, try to go through as many points as possible. Here I could only go through one. Second rule, try to have as many points on the right-hand side of the line as the left. Over here I have it 1, 2, 3 on the right. I have 1, 2, 3 on the left, okay? And then the third rule is you want to have that line an equal distance from comparable points, okay? So here I drew it so it was kind of in between the two. It's equal distance between them, an equal distance here between them. And here I have it basically like touching here on the left-hand side of the dot, here on the right-hand side of the dot. So you try to do that. So when you put your ruler down there, you're kind of doing this thing. You're seeing how that will line up, and then you just plop it down, okay? And do it. Now in your books, you're not going to be drawing lines on the thing in your book. You excuse me, use a ruler or a straight edge, and when you determine where that is going to be, plop it down on the book, and then that will be your line. So this is what I did. I went through one point, put equal points on either side of the line. I tried to keep it equal distance from comparable points, okay? And generally, that's what you try to do. Now, in graphing calculators, this is not a graphing calculator, okay? Or in computer programs, that's actually the derivation that they go through to determine, excuse me, the best fit of a line, okay? They try to go through the data points. If not, they split the data points evenly, one side of the line or the other, and then they try to get that line equal distance, okay, from all points. Actually, they use equal of the square root of the distance. We won't get into that, okay? So anyway, that's what you just that's kind of the art form of drawing the line in, okay? So then, our general equation for a line is y equals mx plus b, and they said we don't want it in y and x, we want it in s and n, because in this case, the y corresponds to salt, this corresponds to carbon, the x, so we want salt and carbon instead of y and x. Don't let that throw you. It's just different letters for the variable, okay? But the drill is the same. Once we have our general equation of the line, the first step is to go ahead and determine the slope. Now, what I would recommend is draw the line in the graph, okay? All those graphs have a border around them, and make sure the line extends up to where the line goes off of the graph on both sides of the line, and then establish what that point is. Up here it was rather easy. It crossed, in my view, and again, this is you're estimating where it crosses, but from my view it looked like it crossed right at 160 and then at 10. So my point in the x, this corresponds to the x value, this the y value. My point was 160.10 where it went off the graph on the upper end. And down here now I notice it did not cross at a point, so I had to estimate, okay, if this is from 0 to 40, halfway is 30, that point looks a little bit beyond halfway. I called it 37, okay? And this is, there's going to be a little bit of error, and so they said in the textbook, you know, because of this is graphical solutions, you're not going to get the same exact answer as in the back of the textbook. And if I see a bunch of answers that are like that, I'm going to be suspecting you're just copying them down, because there's going to be error. It depends how you draw the line in, and it depends how you estimate this. I estimated it at 37. Someone else might estimate it at 35. Someone at 38. That's going to change your answer, okay? So my point down here where it went off the graph in the bottom was 37 in the x, or C, and 0, because that corresponds to 0 over here, I should put in the y, okay? So then what is my slope? I go up and, okay, let's figure out my slope. My slope is my rise over my run. And slopes go from left to right. It's going upward to the right. It's going to have a positive slope, okay? My rise is going to be, it rises up to 10 units from 0 units. It runs all the way over to 160 units, and it starts at 37 units. Okay, that's my rise over my run. It comes out to 10 over 123. Okay, when I compute that as a decimal point, I get m equals 0.0813. Okay, and it had some numbers after that. Okay, so I plug that into my equation. S equals 0.0813. C, not using x, I'm using C, plus B. And the drill is the same. Now we solve for the y-intercept. Now, we notice our graph here doesn't intercept the y-axis in the body of my graph. It's somewhere below 0, okay? And that's okay. We're going to use the same way that we did solving for intercept before. We're going to take a known point and substitute in for S and C. I'm going to select this one down here because it has a 0 in. That's going to make the computation, I think, easier, okay? In that case, what is 0? 0 corresponds to the S value, 0.0813. C now is not C, it is what? It is 37. Substitute in plus B. Okay, so then I get B will equal, when I take this to the other side, it will become a negative. Okay, and when I do it on my calculator, it came out to 3.008. Okay, so what do? I take that value for B. That is now my intercept, minus 3.008. Okay, that is the equation that I would use for that line I drew in. Okay, now they use different decimal points, and you can use as many as you would like. It's up to you. I would like to use at least 3 numbers in the decimal number to do that. Why I used 4 here? Because after the 3, it went to 0 as the next number. So it's up to you how you want to do it. Now notice in the book, they said they had those 2 lines there. It said they had 2 possible equations from those 2 lines, one to the extreme left, one to the extreme right, okay? And it says your value for the slope should fall between 0.05 and 0.1. Minus 0.08 falls in between there. And they're saying the intercept based on those 2 extremes should fall between +1 and -4. Mine is at -3. And why -3? Because the y-intercept is going to be crossing the y-axis below 0, down there. I estimated it'd be at 3.008. Okay, so it's the same drill for determining the equation of the line. Find out the slope first, then plug in a known point. Pick one that will, if you got a 0, that's helpful, okay, to plug it in, and then find your intercept. Then plug it into the equation. Yeah, it looks a little bit different than we're used to, because it doesn't have the x and y, and it has these long decimal numbers, but that's what you get in science, engineering, technical graphing of lines, okay? So the trick is, okay, draw it accurately, use a straight edge, and then take your values where they cross, okay? And you can show me those so I can see what points you're using to determine your slope. So I hope that helps. Shoot an email or a text message with any questions that you have. So long for now.